Use logarithms to evaluate 34.33 over square root of 5.25 times 0.042. From the log tables, the log of 34.33 is 1.5357. 1.5357. The standard form of 34.33 is 3.433 times 10 power 1. So this is 3.433 times 10 power 1. This power 1 is what is here. Then we go to the log table. We find the log of 3.433, which is 0.5357. Then now we come here. 5.25. The log of 5.25 from the log table is 5.25. The log of 5.25 from the log table is 0.7202. The standard form of 5.25 is 5.25 times 10 power 0. 10 power 0 is just like 1. So it is 1 times 5.25, which is still 5.25. So this 0, we bring it here. It is 0 here. We bring it here. Then we go to the log table to find the log of 5.25, which is 0.7202. Then we find the log of 0.042. From the log table, it is bar 2, bar 2.6232, bar 2.6232. The standard form of 0.042 is 4.2 times 10 power 1, 2. 10 power 1, 2. 10 power negative 2. So this negative 2 is bar 2 here. Then we check from the log table, the log of 4.2 is 0.6232. Now we want to add. Because we are dealing with 5.25 times 0.042 in the denominator. So when we add, we end up getting this is 4, 3, 4, 3, bar 1. We end up getting bar 1.3434. And now we want to find 5.25 times 0.042 raised to the power of 1 over 2. That means that this is going to be bar 1.3434. We divide by 2. So when we divide this by 2, we end up getting bar 1.6717. Bar 1.6717. So So now we can bring it up here. We can bring it up here. This is bar 1.6717. Bar 1.6717. And now we subtract the denominator from the numerator. So that is 1.5357 minus bar 1.6717. So when we subtract, we end up with, this is 0, 7 minus 7, 0, 4, 6, 8.1. That is 1.8640. 1.8640. Then we go to the antilog table to find the antilog of 1.8640. So this one we can write it as 10 power 1 times the antilog of 0.8640 from the antilog table is 7.311, which is giving us 10 power 1 times 7.311 is 73.11. 73.11. So this is our final answer. Dividing and adding logs. Number logs. 0.5127 plus bar 2.7292. How do we add this one? 7 plus 2 is 9. 2 plus 9 is 11. We carry 1. 1 plus 1 is 2. Plus 2 is 4. 5 plus 7 is 12. We carry 1. 1 plus negative 2. 1 plus negative 2 is equal to 1 minus 2, which is equal to negative 1, which is equal to bar 1. So this is bar 1. Bar 1. Then now, bar 1.2419, we want to divide by 3. How do we divide it by 3? We can write 1.2419 as a negative 1 plus 0.2419. Bar 1 plus 0.2419. We can also write it as bar 1 and this is divided by 3. This is divided by 3. Now we want to find an exact number we can divide by 3 here, this other side. So we can say that this is minus 1 minus 2 plus 2 plus 0.2419 divide by 3. We want to get an exact number we can divide by 3 here. So that's why we have minus negative 2 here. We have subtracted negative 2 here. So negative 1 minus negative 2. So this is going to give us negative 3. And we can divide negative 3 by 3. So we have used negative 2 here. And because we have used negative 2 here, we must add it this other side, plus 2. When we add it this other side, it means that we have done nothing, because negative 2 plus 2 is 0. Still we are going to end up with a negative 1 here. So this 2 we bring here, then we add to 0.2419. So we are going to have negative 3 plus 2.2419. We divide by 3, we divide by 3. So when we divide by 3 here, this is negative 1 plus negative 1 plus, this is negative 1 plus 0.7473. This is when we divide this by that, we get 0.7473. So this is giving us about 1.7473. By 1.7473. And this one we can write it as, we can find the antilog of by 1.7473. This other side we can write it as 10 power negative 1. By 1 is negative 1 times the antilog of 0.7473 from the antilog table is 5.589. So when we multiply 10 power negative 1 times 5.589, we end up with 0.5589. 0.5589. Use logarithms to evaluate 3.256 times 0.0536 raised to the power of 1 over 3. From the log table, the log of 3.256 is 0.5127. From the log table, the log of 3.256 is 0.5127 The standard form of 3.256 is 3.256 times 10 power 0. This 0 is what is here. 0, we put that 0 here. Then we go to the log table to find the log of 3.256, which is 0.5127. From the log table, the log of 0.0536 is bar 2.7292. Bar 2.7292. The standard form of 0.0536 is 5.36 times 10 power 1 2. 10 power 1 2 negative 2. 10 power negative 2. So this negative 2 is what is here, bar 2. Then we go to the log table to find the log of 5.36, which is 0.7292. And because now this is 3.256 times 0.0536, we multiply them together, and in log form we add this one here, we add. So when we add, we end up with bar 1.2419. Bar 1.2419. Then now this is 3.256 times 0.0536 raised to the power of 1 over 3. So we raise this one to the power of 1 over 3. So it means that this is about 1.2419. We divide by 3. So when we divide this one by 3, then it means that we are going to get 1.7473. 1.7473. Then we go to the antilog table. So here we can write this one as a 10. We can write here this one as a 10 power negative 1 times bar 1 is 10 power negative 1 times the antilog over 0.7473. From the antilog table, the antilog over 0.7473 is 5.589. 5.589. So when we multiply 10 power negative 1 times 5.589, we end up with 0.589. 0.5589. And this is our answer. Dividing, adding and subtracting logs. Number, log. 0.7202 plus bar 2.6232. How do we add it? 2 plus 2 is 4. 0 plus 3 is 3. 2 plus 2 is 4. 7 plus 6 is 13. We carry 1. 1 plus negative 2. 1 plus negative 2 is equal to 1 minus 2, which is equal to negative 1, which is equal to bar 1. So this is bar 1.3434. How can we divide bar 1.3434 by 2? So we can write this as a negative 1 plus 0.3434 divided by 2. We want to find an exact number. We can divide by 2 here. So we can say that this is a negative 1. We can subtract a number that when after subtracting we can divide it by 2 to get an exact number. We can say that this is negative 1 minus 1. Negative 1 minus 1 is going to give us negative 2, and when we divide negative 2 with 2 we are going to get negative 1. So this is negative 1 minus 1 plus, when we subtract this number negative 1 from this side, we must add it this other side, so that we can say that negative 1 plus 1 is going to give us 0, which means that we have done nothing and still we remain with negative 1 here. So we say this is negative 1 minus negative 1 plus 1 plus 0.3434 divided by 2. So we can say that negative 1 minus negative 1, this is negative 2, we divide by 2 plus 1 plus 0.3434, that is 1.3434, we divide by 2. So this is giving us negative 1 divided by negative 2 divided by 2, that is giving us negative 1. Negative 1 plus 1.3434 divided by 2, we end up having 0.6717. 0.6717. So here this is giving us a negative 1 is bar 1. Bar 1.6717. Bar 1 negative 1 minus 1 is negative 2. We divide by 2 plus 1 plus 0.3434 is 1.3434. We divide by 2. So negative 2 divided by 2, we get negative 1 plus 1.3434 divided by 2, we get 0.6717, which is equal to bar negative 1 is bar 1, which is equal to bar 1.6717. Bar 1.6717. Now let us subtract 1.5357 minus bar 1.6717. How do we subtract it? 7 minus 7 is 0. 5 minus 1 is 4. 13 minus 7 is 6. We remain with 4 here. 14 minus 6 is 8. We borrow 1 here. It becomes 14 here. 14 minus 6 is 8. Then we remain here with 0. So now 0 minus 1. Here 0 minus 1 is equal to 0 plus 1, which is equal to 1. Which is equal to 1. So here this is 1. Then now we can go to the antilog table. We can say that this is a 10. This is 10 power 1 times the antilog 10 power 1 times the antilog of 0.8640. The antilog of 0.8640 is a 7.311. So when we multiply 10 power 1 times 7.311, we end up with a 73.11. 73.11. Adding and subtracting logs. Number log 0.6592 plus bar 2.5798. How do we add it? 2 plus 8 is 10. 9 plus 9 is 18. Plus 1, 19. We bring 1 here. 1 plus 5, 6. 6 plus 7, 13. We bring 1 here. 1 plus 6 is 7. 7 plus 5 is 12. We bring 1 here. 1 plus negative 2. 1 plus negative 2 is equal to 1 minus 2, which is equal to negative 1. Negative 1 is bar 1.2390. How can we subtract bar 1.2390 minus bar 1.9138? This is 0. We borrow 1 from this side, 9. This one becomes 10. 10 minus 8 is 2. The remainder here is 8. 8 minus 3 is 5. 3 minus 1 is 2. We borrow 1 from this other side. 12 minus 9 is 3. So we have borrowed 1 from this side. Negative 1 here. We have borrowed negative 1. And therefore here this is a negative 2. So here is negative 2. We are remaining with negative 2 here. Negative 2. So negative 2. Negative 2 is here. We want to subtract negative 1. Negative 2 minus negative 1 is equal to negative 2 plus 1, which is equal to negative 1, which is which is bar 1. Bar 1. So therefore this is a bar 1.3252. How can we divide bar 1.3252 with 4, or we multiply with 1 over 4? Multiplying this with 1 over 4 by 1 over 4 is just like dividing it by 1 over 4. So how do we divide it? We can write this as a negative 1 here plus 0.3252. Here we divide by 4, or we multiply by 4, and we want to find an exact number. We can divide by 4 here, so we can say that this is negative 1 minus negative 3 plus 3.3252. We multiply by 1 over 4. Negative 1 minus negative 3 is negative 4. We have subtracted negative 3 here, then we have added positive 3 here. So it means that negative 3 plus positive 3 is 0. So it means that we have done nothing here. Still, this one remains as negative 1 plus 0.3252. So negative 1 minus negative 3 is negative 4 plus 3.3252. We divide here by 4, we divide here by 4. So when we divide by 4, we end up with negative 1 here, plus 0.8313 when we divide here, which is equal to bar 1.8313, which is here. So now we can find the antilog here. This is 10 power negative 1, bar 1 is 10 power negative 1 times the antilog of 0.8313, which is equal to 6.781. When we multiply 10 power negative 1 times 6 times 7 times 6.781, we end up with 0.6781, and this is our answer. Use logarithms to evaluate 55.9 divided by into bracket 0.2621 times 0.01177 raised to power 1 over 5. So from the logarithm table, from the log table, the log of 0.2621 is bar 1.4185, bar 1.4185. The standard form of 0.2621 is 2.621 times 10 power 1, 10 power negative 1. So this negative 1 is by 1 here. Then we check the log table for the log of 2.621, which is a 0.4185. From the log table, the log of 0.0177 is a bar 2. Bar 2.0708. Bar 2.0708. The standard form of a 0.01177 is a 1.177. 1.177 times 10 power 1 2 power 1 2 power negative 2 power negative 2, and this negative 2 is bar 2 here. So now we want to multiply 0.2621 by 0.01177. So when we multiply, it means we add. So when we add, we end up with bar 3.4893. Bar 3.4893. Then now we want to find 0.2621 times 0.01177 raised to power 1 over 5. So it means that this one is going to be bar 3.4893. we multiply by 1 over 5, which is the same as dividing bar 3.4893 by 5, and that is giving us bar 1.4979. Bar 1.4979. Then we go to the log table. 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 We want to find the log of 55.9 from the log table. The log of 55.9 is bar 1.7474. Bar 1.7474. So this is 5.519 here. We divide it by this one here. So when we divide, in fact this expression is just like, we can say it is equal to 55.9 divided by 0.2621 times 0.01177. 0.01177 raised to power 1 over 5, and that is what is here. So now This expression is what has given us this one here. So now this expression is what has given us by 1.4979 here. So we can say that this expression is giving us here, we put this by 1.4979 down here. This one here, we bring it down here. So now this is the numerator, this is the denominator. So we divide the numerator with the denominator. So it means that here we are going to subtract. We are going to subtract. So when we subtract, we end up with 0.2495. 0.2495. Then we can check from the antilog table to find out the number on this other side. So this 0 is 10 power 0. Normally 10 power 0 is equal to 1. 10 power 0, 10 power 0 times, we check the antilog of 0.2495 from the antilog table, and it is giving us 1.776 from the antilog table. And when we multiply it by 10 power 0 times 1.776, we end up with 1.776 as our answer. 10 power 0 is 1, so it is 1 times 1.776, which is giving us 1.776. So this is our final answer. Multiplying and subtracting logs. Number log bar 2.8096 times 1 over 2. We can write it as a negative 2 plus 0.8096. Then we multiply by 1 over 2. Multiply by 1 over 2. Negative 2 plus 0.8096. Then we multiply by 1 over 2. And this one we can write as a negative 2 plus 0.8096. Then we divide by 2. We divide by 2. And this is equal to negative 1 plus 0.4048. And this is giving us by 1.4048. So it is giving us by 0.4048. How can we subtract bar 3.9138 from bar 1.4048? Here, this one here, we can write bar 1.4048 as a minus 1 plus 0.4048. We can write bar 3.9138 as a negative 3 plus 0.9138. Then we subtract. So here we can write negative 1 as a negative 1. We want to take away 1 from this negative 1 here, and we bring it this other side so that we have 1.4048. So when we take away negative 1 here, we say it is negative 1 minus 1 plus, we bring 1 this other side, it becomes 1.4048. You can see that when we take away 1 from negative 1 here and we add 1 this other side, when you compare 1 and 1, this is negative 1, this is positive 1. So negative 1 plus positive 1 is 0. So it means that we have done nothing. Still we are remaining with the negative 1 this other side. But because we want to find a way of subtracting this other side, we bring positive 1 this other side. So this is negative 1 minus 1 plus 1.4048. Then this is a negative 3 here plus 0.9138. Now negative 1 minus 1 is negative 2, negative 2 plus 1.4048, and this one is negative 3 plus 0.9138. So now we subtract. So when we subtract, this is 0, 1, 9, 4.0 plus negative 2, negative 2 minus negative 3 is equal to negative 2 plus 3, which is equal to positive 1. Positive 1. So here we remain with 1 here. So this is giving us a 1.1 plus 0.4910 is 1.4910. 1.4910. 1.4910. So we can go to the antilog table to find the antilog of 0.49110, and this one is written as here 10 power. This is positive. It is positive here. This is positive 1. This is positive. This is positive 1.4910. Positive. So here we can write this as a 10 power. We can write it here as a 10 power 1, 10 power 1, 10 power positive 1 times the antilog of 0.4910 from the antilog table is 3.097, 3.097, which is giving us a 10 power negative 1 times 3.097 is giving us 30.97. 30.97. Thank you for watching, and see you in the next video. Use logarithms to evaluate root 4 over 4.562 times 0.038 over 0.82. So from the log table we find the log of 4.562. The log of 4.562 from the log table is 0.6592. The standard form of 4.562 is 4.562 times 10 power 0. So this 0 is what is here. Then we find the log over 4.562, which is 0.6592. Then we find the log of 0.038. From the log table it is bar 2.5798. The standard form of 0.038 is 3.8 times 10 power 1, 2, 10 power negative 2. So this negative 2 is what is bar 2 here. Then we check from the log table the log over 3.8, which is 0.5798. So now we want to multiply 4.562 times 0.038. When we multiply it in form of log, it means that we add, and when we add, we end up with bar 1.2390, bar 1.2390. Then we go to the log table to find the log of 0.82. The log of 0.82 is bar 1.9138, bar 1.9138. The standard form of 0.82 is 8.2 times 10 power negative 1, power negative 1, and this negative 1 is this bar 1. Then we check from the log table the log of 8.2, which is 0.9138. So now we come here. We can write this one as 4.562 times 0.038 over 0.82 into bracket raised to power 1 over 4. Power 1 over 4. So this is what is here. So now we want to divide the numerator and denominator. So we divide the numerator by the denominator. So we can say that this is now we are going to subtract. We subtract. When we divide the numerator with the denominator, it means that we subtract. So when we subtract this one by 1.2390, we subtract by 1.9138. We end up with by 1.3252. By 1.3252. So from here it is by 1.3252. Now what about this one here? So it means that we can put by 1.3252 here, then we multiply by 1 over 4. We multiply by 1 over 4, and when we multiply by 1 over 4, it is just like dividing by 4, which is giving us by 1.8313. Then we can check the antilog. This is going to be 10 power negative 1 times the antilog of 0.8313 is 6.781, which is giving us a 0.6781. So our final answer here is going to be 0.6781. 0.6781. 0. Use mathematical tables to evaluate square root of 0.0645 over 0.082. We can write this as a 0.0645 to the power of a half over 0.0082. From the log table, the log of 0.0645 is by 2.8096. How do we get by 2.8096? 0.0645 can be written in standard form as 6.45 times 12 times 10 power negative 2. So negative 2 is the by 2 here. Then we get the log of 6.45 from the log table, and it is 0.8096. Then now let's find 0.0645 to the power of a half. So it means that we multiply this by 2.8096. We multiply by a half, or we divide by a half. And when we divide it by a half, we end up getting by 1.40487. We end up getting about 1.4048 by 1.4048. Then we go to the log table. We want to find the log of 0.0082, and it is by 3.9138. In standard form, 0.0082 is 8.2 times 10 power 123, 10 power negative 3. So this negative 3 is the one that is by 3 here. Then we find from the log table the log of 8.2 is 0.9138. Now we want to divide 0.0645 power half by 0.082, which means that here we subtract. So when we subtract, we end up here with 0, 1, 9, 4, and 1. So that is 1.4910. Then we go to the anti-log table. So this one here will become 10 power 1. 10 power 1 times the anti-log of 0.4910 from the anti-log table, which is 3.097. 3.097, which is equal to, when we multiply 10 power 1 times 3.097, we end up with 30.97. 30.97. Therefore, our solution here is 30.97. 30.97. Thank you for watching, and see you in the next video.